welcome to Mr. Franklin Explains Some Math. Here we've got, we're looking at the vertex of a parabola when it isn't where you would expect it to be. Let's look at one that we already know how to work with. Here, y equals x minus 3 times x plus 5. At this point, we should be able to switch the signs on this and see that the x-intercepts are 3 and -5. And let's look at a graph of that. You can see that the x-intercepts are 3 and -5, and we want to look halfway in between those. Doing a little quick math, I see that the line of symmetry, here it is, happens at -1. And we can see that the vertex happens at the same value of -1. Looking at this algebraically, if we know that the vertex is -1 at the x component, we can find the y component simply by plugging that x, -1, into the equation that we have, and doing a little quick math, we can see that this, let's see, -1 minus 3, that comes out to be -4, times -1 plus 5, that comes out to be +4. And of course that means that our y value for the vertex comes out to be -16, which, since I showed you that on the graph, should not be a real surprise. So we can see that the vertex here happens at -1, -16, right where we would expect it to be. There it is on the graph. But wait, what if something else happens here? So see this equation right here? Y equals 2 times x plus 2 times x minus 4. What we've seen in the past is out here in front of these parentheses, we've seen a negative sign out there, which turned it into a downward opening parabola. But what if we've got a number out here that's not -1? Instead, this is +2. We're going to take whatever the values of x plus 2 and x minus 4 are, and we're going to multiply the whole thing by 2. That's going to change where the vertex is going to be. Now, our x-intercepts are still at the same place as we would expect them to be. When we plug -2 into this equation, -2 plus 2 cancels out, giving us a result of 0. That's what we're looking for. +4 is the other one. Multiplying 0 times 2 doesn't change it. Halfway in between -2 and +4, we're going to find +1. And the vertex we're looking for is right on that same line of symmetry. So the x value of the vertex is still going to be +1. Back to our algebraic solution here. When we plug 1 into this equation, let's see what happens. 2 times 1 plus 2, that's what I meant, and 1 minus 4, that's going to change what we've got going on here just a little bit, because I've got 2 times 3, of course, and then 1 minus 4 is -3. And what this says to do is take 2 times 3 times -3. Just a quick calculation should tell me that the 3 times -3 is -9. Now, if this 2 wasn't here, the y component of the vertex would be -9. But of course, with it there, it changes it a little bit. Just a little bit, and that comes out to be -18, giving me a vertex of -18. See, what happened here on the graph is that when I put this 2 out in front, it changed where the vertex goes. The vertex is still along the blue line that you see, which is the line of symmetry where x equals 1. And any value that I put in front of here is going to change where the vertex appears, but the x value of that vertex is still always going to be 1, which is halfway in between the x-intercepts. So, what we've learned here is that when you have a value that is bigger than 1 in front of our 1 plus 2 and 1 minus 4 in front of our equation, which you can see here, then we end up with the vertex moves either up or down, in this case down. Instead of being at -9, it's at -18. Now you should go ahead and try a couple problems on your own. Here's a couple of other problems here that will help you understand what's going on.